Hello everyone. Today we'll be talking about optics. Have you ever wondered what are optics? Optics, simply put, can be defined as the study of light and is felt by everyone in the world. So there will be no person who hasn't felt the effect of optics on us. In optics, we study about the properties, behavior and properties of light along with the interactions of light with matter. Now, you might also think that how do optics help us? Optics help us by providing vision to living organisms, and also it provides us with food through plants which intake food through photosynthesis which requires light. Now, how does it provide vision to living organism? For example, let's take an example of a human. A human, this is stick diagram of a human. So this human intakes food which is received by plants through the sun. Sun is a source of light. This is the sun, which is a source of light. These are the plants which intake the energy from the sun, the light energy from the sun to be specific, and they use it for photosynthesis. Once they undergo photosynthesis, they take up, we are able to get the sunlight. If there were no optics, plants would not be able to carry out the process of photosynthesis. So, we would get no food since all the food is most of the food in this world is provided by plants. It also, the sun being as a source of light, it also provides vitamin D to all life forms on earth, be it grass, be it plants, be it animals, be it microscopic organisms, or let it be a human. It provides vitamin D to all organisms on earth. Now, there's a phenomenon of light which is known as a reflection of light. When light hits a reflecting surface, it bounces off and comes back, which is known as reflection. We can call this as the reflective surface. We can call this as a mirror. Now, what happens is the incident ray which falls here will reflect back in a phenomenon which is known as the reflection of light. This is the IR or the incident ray, and this is RR or the reflected ray. The refracted ray comes when light bounces off the mirror and comes back, while the incident ray itself falls on the mirror. Next, there are some laws for reflection of light. Number one, first of which is that the angle of incidence is equal to the angle of reflection. Now, you might think, what is angle of incidence or what is angle of reflection? Let me tell you. We can call this as a normal or a perpendicular to the mirror. This is the normal. This is the incident ray or the ray which hits the the reflective surface. This is the reflected ray which bounces back after reflection. Normal is a perpendicular to the mirror, to the surface, to the mirror surface. So this and this is a 90-degree angle. So this angle we can call this as, let's call this as angle O, and this angle I. No, let's not call it angle I, angle F. So angle O plus angle F is equal to 180 degree, where angle O is equal to angle F is equal to 90 degrees, which means both of them are 90 degrees. Since normal is a perpendicular bisector on the mirror to which meets at the point of incidence. This is the point of incidence of a mirror. As the word might suggest, this is the point on which the incident ray strikes first. The second law of reflection is that all of these, the incident ray, the normal, and the reflected ray, lie on the same plane. They lie on the same plane. Now, what does lying on a same plane mean? Lying on a same plane means that if we were to draw this diagram on a piece of paper, all the incident ray, normal, and the reflected ray, they would remain on the paper and would not go out of the paper. There are a few types of mirrors which reflect light also. First of which is a plane mirror. As discussed earlier, this is commonly referred to as the plane mirror. This mirror will always form a virtual and erect image. Now, what does virtual image mean? Virtual images cannot be obtained on a Virtual images cannot be obtained on a screen, which means that we cannot obtain the image from a mirror on a screen. Second, you might also think that why do virtual images they cannot be obtained on a screen? They cannot be obtained on a screen because in a virtual image, light rays do not intersect. They just appear to intersect. They do not intersect, but we think they are intersecting. So an image is formed, but this image cannot be obtained on a screen. There is also no change in size of the image formed by a plane mirror. So there is going to be no demagnification or magnification taking place in the image as compared to the actual objects. And the distance between the object and the plane mirror is going to be equal to the distance of its image and the plane mirror. Now let's take an object to be here. I'll undo everything. Let's take this as O, or this is a ball. Let's say this is a ball, and this is its image. Let's call this as image of ball. Now, by the law of reflection, the distance between the ball and the mirror is going to be equal to the distance between the image of ball and the mirror. So there's going to be some distance between the ball and the surface of the mirror. This is equal to the distance which appears to be present between the image of the ball and the mirror. These were the properties of the image formed by a plane mirror. Lateral inversion also takes place in a plane mirror. This means that left side appears to be right in the image while the right side appears to be left. Next, we come up with another phenomenon of light which is known as refraction of light. We will study about convex lenses or convex mirrors and concave mirrors in the next post. Now you might think that what is refraction of light? When light travels from one medium to another, the light's direction changes due to the slowing down in the speed of light. This principle is known as the reflection of light and is also the principle on which lenses work. Now what does this mean? Let's take this to be glass, or let's take this to be a glass. This is glass and this is air, which is medium 1, and glass is medium 2. Light will be going from the air to the glass, but there will be a change in the direction and speed of the light. The direction of the light is going to change. We call this as the incident ray, similar to the plane mirror, but we need not get confused. This. Next up, this is the normal. Normal, as you might have thought, is a perpendicular drawn to the surface of the glass. This is basically a straight line. This is the normal. Now the light which comes out of this glass is known as the emergent ray. This emergent ray has changed its direction. So we can also call this as the aftermath of refraction. Lenses also work on the principle of refraction. Now, how do lenses work on the principle of refraction? This we will learn in our next post. There are two laws of refraction of light. First of which is similar to the laws of reflection of light, the incident ray, refracted ray, and the normal lie on the same plane. Again, this means that if we have a paper, let's say this is our paper. Now we draw a diagram for refraction here. Again, let's take this to be glass, medium 1 or glass. This is also referred to as medium 1, or no, this is medium 2 or glass, because the first medium is air. One or air. Now, according to the first law of refraction, the incident ray which comes like this, and then the refracted ray, and then the emergent ray, they all will lie on the same plane. This means that all of these rays will lie only on the paper and not outside. The second law of refraction is also referred to as the Snell's law of refraction. For this law, there is an important term called refractive index. This refers to the ratio of the speed of light in first medium upon and the speed of light in the second medium. So we calculate the refractive index by this formula. Now you may think, what does this V1 and V2 mean? V1 means speed of light in first medium, and V2 means speed of light in the second medium. In this case, in the glass case, speed of light in the first medium here was air, while the second medium here was glass. So refractive index can be defined as the speed of the light in the first medium divided by the speed of the light in the second medium. We can also call refractive index as the extent to which light changes its direction in the refractive medium. This can be used as a decider as to which how much did the light change its direction in the refractive medium. Now, let's come off to the second law of refraction of light, which is Snell's law of refraction. This law tells us that the sine of the angle of incidence divided by the sine of the angle of refraction sine I upon sine R is equal to the speed ratio of the refractive index of both the mediums. So we can call this as the V1 or speed of light in first medium divided by V2 or the speed of light in the second medium. Now there is another way of interpreting this, and you might also think that what is sine I and what is sine R? We can also say that this is the ratio of the refractive index of indices of both the mediums. Now you might think that what does a sine of an angle mean? In trigonometry, sine of an angle means the ratio of the opposite side and hypotenuse of a right angle triangle. So let's take this to be a right angle triangle. This angle is 90 degrees and sine of an angle according to this definition, according to the Snell's law, the sine of an angle here is equal to the ratio of the opposite side and the hypotenuse. So ratio of the opposite side and hypotenuse. This is the ratio of the opposite side and the hypotenuse. Now you might also think, how do we calculate the sine of an angle if we don't have any measurements with us? For example, they have only given us one angle. Here, theta is an angle. Now, we don't know exactly what angle theta is. So, according to trigonometry, theta is an angle which is not the right angle. So, this is very easy to understand that it is not the right angle. This is the theta of an angle. This is the theta angle, or we can refer to this as the theta angle. Now we have some terms here. You might think that if it was that easy, how do we solve it? There are some specific values of the sine of an angle which are expressed in a trigonometric table. But before that, we need to learn what does sine theta mean. What does the sine of the angle theta mean? Oh, let's draw the diagram again. Let's draw the diagram again. Now theta is a variable used to express an angle. According to this, sine of an angle is equal to, so let's say this as sine theta. Let's take this to be theta. So sine of theta is equal to the ratio of the perpendicular and the hypotenuse. Sine theta is equal to the ratio of the perpendicular and the hypotenuse. Now there are some specific values for each of the three trigonometric functions. These are sine, cos and tan. We express those values as, for example, let's take this angle to be 30 degrees. Let's take this to be 30 degrees. Theta is equal to 30 degrees. So there is a prefixed value of sine 30 degrees, because since theta is 30 degrees, we will calculate sine 30. We will have to remember those values, and I will also be telling a short trick for remembering those values. Sine 30 is equal to 1 by 2. Now what does this mean? This means that the ratio of the perpendicular and the hypotenuse is 1:2, which means the hypotenuse is twice the length of the perpendicular here. There are many conclusions here. Also, I'll be drawing a trigonometric table. As I wrote here, sine 30 degrees is equal to 1 by 2. But how did I get there? There is a specific table which is used to remember the value of each of the variables called sine, cos and tan. But first, I'll be telling what do these trigonometric ratios mean. First up is sine theta. Sine theta. This is expressed as the perpendicular divided by the hypotenuse divided by the hypotenuse. Next, we have cos theta. Next, we have cos theta, which is expressed as the base upon the hypotenuse. But you might also think that what are perpendicular, hypotenuse or base? These are the lengths of some sides in a right angle triangle. So this is a right angle triangle. So here P, this is the perpendicular, or and then this is the hypotenuse. Hypotenuse is the side opposite to the right angle, and this is the base. So we define sine theta as the perpendicular upon hypotenuse, cos theta as the hypotenuse upon base, no, cos theta up as the base upon hypotenuse, and finally tan theta we write tan theta as, guess it, the perpendicular upon base. Now you might notice a relationship between sine theta, cos theta and tan theta. What is it? If you try to notice carefully, we will see that tan theta is basically the ratio of sine theta and cos theta. Sine theta upon cos theta, as sine theta is perpendicular upon hypotenuse, so let's just write it as p upon h, and then cos theta is base upon hypotenuse. Now since we are dividing, we will take out the reciprocal of base upon hypotenuse, so we'll cancel out h and h, so we get perpendicular by base. This is how we get the value of tan theta. Now, in order to calculate trigonometric equations fluently and faster, we have a trigonometric table which describes us with the values of different sine with theta being as an angle. We are given theta, and if we have to calculate sine for that angle, sine theta, there are some specific values. This is defined under the trigonometric table. This will be 0. So first I'm writing sine. So sine of 0 degrees is going to be 0. And then for 30 degrees, it is going to be 1 by 2. For 45 degrees, it is going to be 1 by root 2. It is going to be 1 by root 2, while for 60 degrees and 90 degrees, it is going to be root 3 by 2 and 1 respectively. We'll have to learn the values for sine theta, as there are shorter ways to remember the other values. Next up, we got cos. For cos, we will have cos 0 degrees is equal to 1. And then cos 30 degrees is equal to root 3 by 2. And then 45 degrees, it is going to be 1 by root 2, which is same as the sine values for the correspondent. And then we have 1 by 2. And then we have 0. You might have noticed a variation here. All the values of sine are basically interchanged in cos. 0 degree sine 0 is equal to cos 90. Sine 90 is equal to cos 0, and so on. Next, we have tan theta. Now, as I told before, tan is described as the ratio of sine and cos. So, it is sine divided by tan. Smooth this a little bit forward. Will be described as sine upon cos. So this is the ratio of sine and cos. This will remain 0. Tan 0 will remain 0, as 0 upon 1 is 0. Next, tan 30 degrees will be 1 by root 3. Tan 45 degrees is 1. Tan 60 degrees is root 3. And you might have guessed for this one that it will be not defined, since 1 upon 0 is not defined. Now let's get back to Snell's law. If let's consider I, angle of incidence, to be 30 degrees and angle of refraction to be 45 degrees. So by Snell's law we will get that sine 30 degrees is equal to V1 sine 30 degrees divided by sine 45 degrees sine 45 degrees is equal to sine 30 degrees upon sine 45 degrees is equal to V1 by V2. This also tells us about the ratio of the refractive indices of both the mediums. By this, we can also get, since here is an example for the same, we get after dividing root 2 by 2 is equal to V1 by V2. So we have successfully got the ratios of the refractive indices of both the mediums. Now we will continue further with the optics in the next video. Until then, goodbye.